I blast no more. Yo, they call a motherfucker John Doe. Now when I hit that switch, I'm bouncing. More bounce to the ounce and I'm climbing. When I hit that switch, I'm bouncing. More bounce to the ounce and I'm climbing. When I hit that...
Sound waves are longitudinal waves, which means that the air molecules are vibrating in the same direction as the wave is propagating. Such wave motion can be visualized like in this illustration, where the air molecules form alternating areas of high density and low density, which translates to high and low pressure. The mathematical representation of this kind of wave motion can be written as the displacement of the individual air molecules, which equals the amplitude of the air molecules times sine of kx minus omega t. This follows from the fact that the air molecules act as simple harmonic oscillators. The problem is that the motion of the individual molecules is really hard to measure. Also, more often we're interested in the macroscopic manifestation of this particle movement, which is the pressure. So how do we get from an expression like this to something that describes the variation of the pressure? The derivation is done in the book, so I won't repeat it here. I'll just state out the result. We have a bulk modulus multiplied by the amplitude of the particle movement. We also have a wave number, and then we have this cosine term, kx minus omega t. Usually we are not interested in this cosine term, which describes how the pressure varies as the function of location x and time t. Instead, we want to know how much does it vary, the minimum and maximum values. And this is what this quantity BAK tells us. And this is called the pressure amplitude, delta PM. So we can write this as follows: minus pressure amplitude multiplied by the cosine term. Let's have a closer look at the pressure amplitude. So it is B times A times K, and we can develop it further by using the following identities. The bulk modulus can be expressed as density times the velocity squared, and K, as we know, is the wave number, 2 pi divided by wavelength lambda. By using these, we get 2 pi times rho times v times A, which is the amplitude of the particle moment, times f, the frequency. So this is the definition of pressure amplitude, and the interesting fact to take away from this is that if we have two similar sound waves, but the other one has higher frequency, the one with the higher frequency, f, will produce a higher pressure.
Cruising, punk stay up on the nuts at the bone. Pussy nigga had beef, knocked out his teeth. The motherfucker should have stayed his ass.